Hi there! Every module that we will be adding to each shelf of the synthesizer needs of course to be powered up. The easiest way to do that is to have one single power supply unit for all the modules at once, or at least on the same shelf. However, there is still a problem with the power distribution, and to solve it we need some sort of bus that carries the power to all the modules at once. This is exactly what we are going to do in this episode. We will create a power bus, or power rail, which will carry all the necessary voltages for the various modules that will sit on the back wall of each shelf of the synth. Each module will then attach to the closest connector of the rail to extract from it the power it needs. Let's get into it.
Hi there! I am Carlo Carrano, and this is Electronics Engineering Made Easy.
Before even thinking of putting anything inside the shelves, we need to think of avoiding any sort of electromagnetic noise going into and out of each shelf. We want a sound as clean as possible, and also we want that the electromagnetic waves created by the modules are not irradiated in the environment where they can affect other electronic devices. What we need is an electromagnetic interference shield, or an EMI shield. Since I already have talked about this subject in a previous video, I won't go again through the details, but you can watch that video if you are interested in the subject. The link is coming up now on the upper right corner of your screen. Once the shielding is done, we can safely put the power rails into the shelves. Here is what I have done to shield my own shelf system. The material that I used for shielding is copper, which comes in its handy form of a tape, conductive on both sides. I covered with it all the internal walls of the shelf, and later on I connected such shield to the ground. I started by measuring an amount of tape enough to cover the whole length of the shelf, and then added some more to be able to overlap the pieces from the various walls. I peeled one end of the tape and attached it to the edge of the bottom panel of the shelf. I was careful to have the tape sitting flush with the external edge of the shelf, and I also made sure it was covering a little piece of the side panel, so the copper tape that I put on it later on had a good electric contact with the one on the bottom. A piece of cloth helped in sticking the tape without air bubbles, while I kept moving the paper from its back and stick it in place. The tape is extremely thin, so it is difficult to avoid imperfection while laying it. That doesn't really matter, it is just aesthetic and it won't be seen anyway once the shelf is filled with modules. Be careful though when you handle the tape, because it is really thin and very sharp on the edges. I even cut myself while I was applying it. Also avoid making the tape go out of the edges, but if that happens, like in this case, you can just cut the excess with a sharp knife. I continued applying the tape with the same procedure and covered all the inside walls of the shelf, and here is the final result. You can see here both shelves completely shielded against the EMI. And this is how it looks like before attaching the power rails on the back walls. Let's talk now about how to make the power rails. I'll do that with some drawings to make it more clear. First of all, we need a long support that goes from one end of the shelf to the other. On this support, we will allocate 6 little boards at equal distances from each other. Each of these boards will have 3 connectors on them, where we can attach each module on the shelf to power it up. Each of these boards is connected to the adjacent one with 8 wires, carrying the voltages needed for the modules. The whole thing is basically a power bus. At one end of this structure, we will connect the actual power supply. Let's now take a look at one of these boards. They are all the same, and each one will have 3 connectors on top, and each connector will have 4 pins. The modules will attach to these connectors to get the voltages made available by the power supply. Now, if the connectors have only 4 pins, why there are 8 wires that connect each adjacent board? The reason is to distribute the current across 2 wires for each voltage, to minimize the resistances on the bus and thus reducing the voltage drop on the bus to a minimal. And so, different pair of wires attached to the board will carry a different voltage. I have chosen to use plus and minus 12 volts for the analog circuits, but I am also distributing a plus 5 volts, useful to power the digital chips that inevitably will be used for some of the modules. And of course, there will be also a pair of wires for the ground. On the 3 connectors, each pin will be connected to a specific pair of bus wires, in this specific order. From the top, plus 12 volts, plus 5 volts, ground, and minus 12 volts. Each module of the synth will use one or more of these connectors to get these voltages. As an extra precaution, to make sure that we handle short bursts of current along the bus, there will be 100 microfarad electrolytic capacitors between each voltage and ground, on each board of the rail. And there is also a 100 nanofarad ceramic capacitor to help filter out high frequencies that could be injected by the modules on the bus. And so here is the whole schematic for each of the 6 boards that make up the power rail. Let's see now how all of this is done. I made the bus support out of plastic using a 3D printer, but since it is too long to print in one solution, I ended up dividing it in 6 equal parts, which I could later join together with screws. This is the single element of the support. This one is the side where all the cables will run, and this is the visible side where the boards with the connectors and capacitors will be located. There are 2 holes for the screws that will hold the bus in place on the back panel of the shelf. Then there are 4 holes to attach to the boards of this base, and a couple of slits through which the wires that run on the other side will be able to reach the 2 ends of the board. And of course, I had to create these wings to attach one piece of the support to the next, using 2 more screws. Here is one of the printed elements of the support. Now you can clearly see where the board will be attached and where the wires will run through on the bottom side. There is also this extra channel to lay down some extra wires, just in case we might need them in the future to connect something at the 2 ends of the shelf. Talking about the boards that go on the support, here is a more formal schematic of them. As we already said, the power rail will use 6 of these boards. Each board connects to the next one through these 8-pin connectors, and the synth modules will be powered through the 4-pin connectors. On each board there is 1 electrolytic capacitor and 1 ceramic capacitor for each of the voltage lines, which will act as a filter for low and high frequencies respectively. To make the boards, I started putting the 4-pin connectors on them, making sure that they were all oriented the same way. The orientation is important to establish the right order for the voltages on the pins. Remember, the one on top will be the plus 12 volts, the next will be the plus 5 volts, then the ground connection, and finally the minus 12 volts. You might have also noticed that the connectors are not symmetric, and this will prevent actually mistakes when plugging in the modules, making sure that they receive the correct voltages on the correct pins. After soldering the 4-pin connectors, I formed the wires so that they go through each voltage line as per the schematic, and I soldered them in place. I did this first with the 2 outer lines and then the 2 inner lines. Note the technique I used to hold in place the wires when I soldered them. I love those tweezers. It was also important to use a very thin solder wire to avoid putting too much solder on the connector pins, with the risk of shorting them out. In my case, I used a solder wire 0.6 mm thick. I used bare wires for the connections to make the assembly easier, and I have to say that initially I tried to use a single long wire for each of the inner lines, but that didn't work out well, as the soldering points were more prone to spread to the nearby ones. It is because of that I ended up cutting little pieces of wire and soldering them at the 2 sides of each pin. This way I was able to avoid short circuits. Once I soldered all the wires, I used a multimeter to make sure that there were no short circuits across the lines. Something like that would be really bad because I would shorten the outputs of the power supply once I connected to the power rail. I then soldered the capacitors on the board. I started with the electrolytic ones, first the one between the plus 5 line and the ground line, then the plus 12 volts, and finally the minus 12 volts, always making sure that the polarity of the capacitors was oriented correctly. Once I finished with electrolytic capacitors, I soldered in place the ceramic ones, which I put in parallel to each of the electrolytic. Next, I soldered the 8-pin connectors at the two sides of the board. Note that once I decided the direction of the first connector, I had to put the one on the opposite side upside down to allow for the voltages to be on the right pins. And of course, all remaining boards had to follow exactly the same layout, otherwise, again, I would end up shorting all the voltages. And here you can see all the 12 modules ready, 6 for the upper shelf and 6 more for the lower shelf. Note the connectors all oriented the same way, both the 8-pin ones and the 4-pin ones. The support pieces will be attached together like this, and as we said, each will host a board with 3 connectors and corresponding capacitors. Since we are going to have 6 of these elements, we are going to have also 6 boards with 3 connectors each, for a total of 18 connectors, which are more than enough to power any module we want to put on the shelf. I'm going now to start putting the pieces together to assemble the whole support for the power rail. To hold the pieces together, I used M3 screws, washers and nuts, with the screw heads on the outside and the nuts on the inside. These screws needed to be tightened enough to make the structure rigid, but not enough to break the plastic. And here is the completed support structure. Here is my connectors box, which I always keep around and replenish every time one kind of connector is almost finished. This is the type of connector I have used for the power rail modules, along with this other one for the sides. What we need to do now is to prepare the cables to connect the modules to each other and to build the bus. To do that, I have used this kind of plug-in connectors in pairs connected with wires. These connectors come with no pins in them. The pins are available separately. You crimp the wires on the pins and then you insert the pins inside the connector casings. Let's see how that is done. First, we remove from this metal tape the pin we want to use. We just bend it back and forth until it breaks. Let's examine it. There are 2 pairs of wings on one side, a larger one and a smaller one. These are the ones that are bent over the wire to keep it in place. The other side is the one that actually gets plugged in. Looking closely on the side, this one, there is this other small wing. This is the one that will lock in place the pin once it is inserted in the connector casing. Each of these casings uses 8 pins, and so we are going to need a total of 8 of these pins to complete all the connections. So let's detach the other 7 from the tape. And now we need 8 pieces of wire to attach to these pins. For the wires I used a 20 gauge to minimize the resistance. We want the bus to propagate the voltages across the whole rail without any significant loss. Given the distance between boards on the power rail, I estimated that a length of 16 cm will be enough to make all the connections, and this should be enough to lay down the cable on the back of the supports, make them come out of the slits, and attach them to the connectors of 2 adjacent boards. Here are all the wires I cut to measure for the first cable. There are 4 different colors for them: red for the plus 12 volts, green for the plus 5 volts, black for the ground, and yellow for the minus 12 volts. And once again we use 2 wires for each of those voltages to minimize the resistance losses. To attach each wire to a pin, we need to first remove a little bit of the insulation, no more than a couple of millimeters though. Then we do a little twisting to make sure the strands will stay put. To complete the process, we need to use this kind of crimping tool. This tool is capable of handling different thickness of wires. Also, once we start closing the tool around the pin and the cable, a clicking mechanism will prevent the tool from opening again until it is completely closed. We start by taking the pin, adjust a little bit the distance of the large wings, put the pin on top of the prong of the right sides, and close the tool until it makes the first click. Now push the pin toward the inside of the tool until it stops because blocked by its side wing. At this point we need to hold the pin in place with one finger while we turn around the tool and we fit the wire from the other side. Once the wire is in position, keep pressing on the tool until it closes completely. At that point, it will reopen automatically and will release the pin and the wire perfectly attached to each other. And now, it is just a matter of fitting the pin inside its casing. However, we need to make sure that we put the wire on the right side of the casing, the one where the plus 12 volts is supposed to be, since this is the red wire. For that, let's take a look at the board one more time. The plus 12 volts is supposed to be on the upper side, and the plug-in connector is inserted in this direction, therefore the red wire must be on this side here. Now, we know that the first red wire needs to be on the side of this first notch, and this will be used as a reference for all the other casings. To put the pin in and lock it in place, we now rotate the connector and plug in the pin with the side wing on the top, so that it will fit the slit present on the connector casing. Then we insert the pin and we push it until we hear a light click, which tells us that the wing has been locked in the casing. At this point, if you pull gently, you will see that the wire does not come out anymore. I repeated this process for all the wires in this order, the 2 reds first, then the 2 greens, then the 2 blacks, and finally the 2 yellows. And this is the finished connector with the wires of the correct color in the right order. This connector can be plugged now in the connector of the board. Once all the cables are ready, with one connector at each end, they can be inserted this way inside the support slits and can be attached to the boards on the other side. Note that the cables are inserted across different units of the support, since they have to connect the boards that sit on each individual element. So these are all the cables needed for connecting the board on both of the power rails, one for each shelf. There is a total of 10 of them, since they just go in between boards, 6 boards, and therefore 5 cables. Here is how to insert each cable on the supports. And here is the whole power rail with all the connectors ready to be attached to the boards. However, there is still one more thing I needed to do, which was laying down a couple more wires in the side channel of the support. As I said previously, these wires have no specific use for now, and I might end up not using them at all. I put them just in case I will need to connect something at the 2 ends in the future, something that right now I cannot think of. Think of it as a life-saving rope. You don't use it unless it becomes necessary. So, I just had to cut to length a couple more wires, for which I chose the blue and white colors to make them different from the other wires running alongside. And I just used some pieces of masking tape to keep the wires in place until the support is fixed on the back of the shelf. Finally, I used a couple of zip ties to hold the excess wires rolled on at the 2 ends. If I ever need to use these wires, I just have to cut the ties, unroll the wires, and use them without having to remove the whole rail from the shelf. After the laydown of the cables was completed, I started working on assembling the boards to the support. To do that, I used 12mm standoffs to raise a little the boards from the surface of the support. I started attaching all the standoffs first, using washers on the front side to avoid the thin standoffs to be pulled through the support when tightening the screw on the back side. Once all the standoffs were assembled, I started mounting the boards. I started from one end and worked my way toward the other end. First I attached the board to the first connector. Then I used the pliers to help bend the cable wires so the board could sit on the standoffs. I did it that way to avoid applying too much force directly on the connector, which could make the wires break at the pin's attachment. Once the board was in place, I used 4 screws to attach it to the standoffs. Then I moved to the second board. First I plugged in the connector from the side of the other board, and then I bent the wires, like before, to sit the board on the supports and the standoff. I used 2 screws to connect the board on that same side, and finally I plugged in the connector on the other side and repeated the same process to finish installing the board. Before moving on the next board, however, I used a multimeter to check the continuity of the bus to make sure that the side 8-pin connectors were doing their job effectively. Then I continued adding boards with the same method and testing the connectors at each step until I finished the whole power rail. I finally repeated the whole procedure for a second power rail, since I had prepared a 2 shelves case. At that point, the last thing that needed to be done was the installation of the power rails inside the shelves themselves. The power rails need to sit on the back panel of the shelf and to the top of it to leave space on the bottom to connect the transformer of the power supply. We will talk about that in the next video of the series. To fix the power rail to the panel, I used wood screws long enough to go through the support and into the wood for about half of its thickness. When you choose your screws, make sure they are not too long, otherwise they will show up from the back of the shelf system itself. Here is a view of the rail once installed on the top shelf. And here is a view of the 2 shelves system with a power rail on each of its shelves. This concludes today's subject. In the next video of this series we will talk about the power supply system for the synthesizer, we will build the very first module, and we will install one of it on each of the shelves. If you liked what you have seen and you would like to continue watch my videos, don't forget to subscribe and to click on the notification bell, so you will be informed automatically when new videos come out. And of course, don't forget to give me a thumb up. In the meantime, I'll see you in my next video, and as usual, happy experiments!